This is Aishwarya Goyal.
And I'm Nilesh Agarwal.
From Towards
Scaling
Reza.
Inference.
Hi, Reza. Thank you so much for joining us today. Yeah. So Towards Scaling Inference is a place where you can learn about ML deployments from zero to scale. We are very excited to have Reza from Dropbox with us today. He's working as a senior engineering manager at Dropbox, where he's leading and managing the strategy, roadmap, and execution of the cross-functional AI/ML products. He has an overall of 17 plus years of industrial work experience in machine learning, big data management, experiments, and analytics. Thank you, Reza, for joining us today.
Thank you very much, Aishwarya and Nilesh, to inviting me for this podcast, and I'm pretty excited to talk to you.
Great. So Reza, directly jumping onto the interview. So we would like to start the interview with the first question, where would be great to understand that what kind of business problems are you solving through AI?
Cool. Yeah, that's a great question. Right now in Dropbox, I'm responsible for overseeing the strategy, roadmap, and execution of AI and ML products related to the consumer targeting and intent understanding, product and feature recommendation, growth funnel optimization, and the experimentation. So as part of my role, I'm also responsible to understand the different stakeholders' needs, and the problem and pain point, and how we can leverage machine learning to solve their own problems efficiently. And, as you know pretty well, that having the ML products needs lots of analysis of the complex data, and to understand the pain point and real problem of the situation happens in the business. So we are working closely with the different stakeholders like data scientists, PMs, growth manager, to understand and scope the problem very well in that domain. And about the areas that I mentioned, for example, the consumer targeting is one of the main points. It is growth, is that to how we can expand the consumer base and a user base of different features and products. So by using and leveraging machine learning, we try to understand the similar users and lookalike users and target them for the product, to make sure that we get the good adoption of the product, and then it's ended to the good monetization of those products in our domain. And for the product recommendation, Dropbox is the SaaS company, so we're bundling different things, different products, different services in the different bundles, and we wanted to make sure what bundle is suitable for your need and your action for the customer. So it's serving as a self-serve, environment, and by understanding user intent and interaction with the Dropbox, we try to recommend the best bundle or best package for our customers, to make sure that they're happy and have a good experience with the Dropbox. And third one is related to the growth funnel optimization. As you can know, that in a growth funnel, you have the different layers in the business: the acquisition, activation, retention, referral, and revenue. How in different phases of the consumer journey try to understand the user need and connect it to the correct workflow in all of our effort in Dropbox. So these are the main challenges that we are facing, and machine learning is the initial suspect, an initial tool and powerful tool to leverage in this area and solve those problems.
Got it. No, sounds like very interesting use cases, and would like to understand that how do you currently deploy these models in production? Like, do you work with managed services like AWS, or have you built your own ML infrastructure from scratch? And would be great if you can also emphasize on the pros and cons of the approach that you have taken.
Absolutely. That's a great question. The main ecosystem that we built is based on the AWS and the famous open sources. For example, for the orchestration and and the workflow, we mainly are using the for the Airflow workflow, we mainly using the Airflow, and for the many of the machine learning inferences, we use the AWS services like the SageMaker, as our main weapons. And for also Spark is also one of the main tools that we are using in the ecosystem. So to answer your question, we're using the combination of the hybrid environment of the open source tools and also the cloud services on top of that. And in recent effort, we wanted to switch from the Airflow, as an example, you content flows you mentioned, to switch from the Airflow to a Kubeflow because of some decision that we made based on the benchmark that we did about the scalability, flexibility, and performance of the ML deployment. And Kubeflow is much more fine-tuned and designed in the area for the machine learning. So we wanted to switch to the Kubeflow on that, and also the strategy of the company is also switch to the Kubernetes, for all the deployment. So it has the friendly ecosystem of the tools that we wanted to have. So in that area, one of the constraints that we wanted in organization-wide, we wanted to have to make sure we select the tools and the platform that are friendly work together. So it's a friendly ecosystem of the tools. So yeah, these are the main tools and infrastructure that we are using for the development using the ML ops or other operations.
Got it. No, this is awesome, I think, Reza. And just want to understand when you're deploying these models, like, do you have one standard format like PyTorch, TensorFlow, or do you use some kind of quantization techniques to convert them into like ONXX and TensorFlow to optimize the model? I just want to understand that part.
That's a great question. It depends on the use cases. For example, for some use cases that the explainability of the model is important, we are not using the native, format on that because, for example, we're working with the marketing people and once we drive the model for that, they're also very interested to know what is the explainability of a model, what is the driver, if there is any bias on that. So we use the native format to make sure that the information is not lost in them, because as a standard, we're using the SHAP values, for doing provide that sort of the explainability. And once you use the ONXX format, that will be lost in that format. So we make sure for those use cases, we follow the native format. But for other use cases that we have, for example, other deep learning models related to the text analysis, the explainability is not important things, and the portability is the main things. We followed the ONXX format for that. So we have both of them, depends on the use case and the requirement from the stakeholder customers. We follow those process. Yeah.
Got it. No, this is super helpful, and especially the distinction of how do you make that decision. That I think would definitely help our fellow MLOps followers to understand that whenever the portability is the biggest thing, then it's a good idea to go with ONXX. Right? So, and how has your experience been in terms of ONXX? Like after conversion to ONXX, has deployment been smooth, or what are the challenges that it helped you surpass? Would love to know a little bit more on that.
This is one thing that is from the execution. It's one format, one standard format that everyone follows. From the code base, from the execution, is very automated. It's not many challenges to think about the different format that we have for different environments. So that's pretty much from the software engineering perspective and ML operation, it's pretty much smooth. For portability, for the execution running, it's very fast. But the main pain point is that depends on the use cases, that if the explainability of the model important. For example, we should use the the XGBoost, those kind of format. And we use the native format to save, to save it as in our format. And mainly converted to the JSON format, to make sure that the explainability there, once they ask us about the drivers of the model and they want to know more about why the model is doing it that way, we use that kind of the format. So yeah.
Got it. No, this is super.
Did I answer your question?
Yeah, no, it did. It did. So in terms of portability, it helps you deploy environment, not worry too much about the environment. So all of them have a standard format and they can just push that and they don't have to worry about MLOps. That's super helpful. So just wanted to understand in terms of your inference workload, right? Especially since you have these diverse variety of models, are there scenarios like real-time batch streaming and what are the use cases that are very specific in Dropbox to all of these three modes of inference, I would say? And how have you built support for all of these?
That's a great question. Depend on the use cases. As I mentioned, we have the three. We can, from the engineering ML perspective, we have the batch, real time, and the stream kind of operation. So yeah, we have for all of them, the use cases that we have. For example, once we need to the internally, for as an example, when the user is logged in and interact with the data with the Dropbox. So we have the real-time model that try to understand based on the short behavior of the user, what could be the best plan, recommend the best plan or best bundle for the users. So that model is totally working in the real-time environment. Yeah. And but we have the other models that are working in a batch mode that, based on the, when you have the long-term users, working that 3+ months, the customer of the Dropbox, they have more interaction with the tools, with the features. So we collected the whole interaction data and we have the other models that are working to, for example, recommend new features to the related person. For example, we found out that you're very interested and working lots with the video files. So we have the product called the Capture that recommend you in a correct time, correct context, that product to you. So that models mainly just is derived based on the batch operation for long-term user interaction. And those kind of models have the more accuracy in general because they collected more data about you. And for the execution, we have two different pipelines, for those kind of models. The first one, the batch model, is mainly using the heavy lifting ETL operation and ML inferencing that we leverage a lot Spark and the SageMaker in that domain to make the inferencing happens. And for the real-time model, we just we use some based on the input of some cache data and some other information. It's going into real-time inferencing, real-time API that happens with the contraction with the users. So this is the ecosystem of the models and the type of the model that we deploy currently, for our use cases. And as I mentioned, just mainly the ecosystem is designed based on the open sources and those SageMaker services in those domains.
Got it. And in terms of, let's say, one versus the other, like real-time batch, especially these two, right? In real time, does compute become an inefficiency, or like let's say if there's something you need in under 100 millisecond or 200 millisecond, right? Do you go to accelerated computing like GPUs, or is most of your workloads on still on CPU based machines for real time inference?
Sure. Yeah, to answer your question, there are a couple of techniques you follow based on the real-time models. There's some techniques using the funneling model with the high recall model start, and then to the high precision model in the machine learning perspective to make sure that you have a very simple, fast model that find the high recall of the user, high potential users, and very granular and the high precision model that select the correct users. So in that case, this is one technique that we are using to reduce that timeline. The second one as you mentioned, we haven't used in our use cases the GPU. The CPU is working well for our cases, but because we also for the real-time model we can hit the SLA that's needed by the product and the APIs less than 100 milliseconds. For that one. For those one, I don't think we have right now in my group any related GPU use cases. If I want to share with you, but those techniques of the CPUs and combination playing around with the model could help us a lot. And also the good point is that it also saving the GPU cost, because usually once you go to the GPU, it's getting more expensive from the part, execution part. So yeah. For our related use cases, we are mainly focused on the CPU base.
Got it. And in terms of any deep neural network that you have, which is more generative, and you have that on a real-time basis, which is offered as a service in Dropbox yet? Yeah,
we have not in my group, but we have other ML groups that work in the video text. They use their own GPU-based model to do this stuff. And we have a couple of those use cases in those domains.
Got it. And those folks run real time on GPU, real time inference on GPU as
mostly, GPU, because once you go to using the heavyweight deep learning, many layers, the standard. So it's much more use the GPU and GPU accelerator, on top of that to make sure the inferencing done. But at the same time, you should also do the trade-off between the cost and the the performance of the algorithm. So it's a trade-off how they can, work in the correct, optimal point for that execution.
Got it. Got it. And since you mentioned that you guys were using a lot of open source tools, especially Kubeflow, to build your runtime, right? So which model serving runtime do you use? Do you look something like a Todd script or a TF serving Triton, something like an open source framework to deploy these models?
Yeah. We're mainly using the TensorFlow.
TensorFlow.
And it's the main framework that we are using right now.
Got it. Got it. And have you written the containers yourself, like the TensorFlow containers, or are you using like open source?
And we're mainly using the following this. What is happens is SageMaker, the standard procedure how to write the container and containerize the workload. So it's something that we do that based on the template. It's straightforward. It's not something. Once you have the model, how to containerize the model, and then we deployed it in the environment. So it's a straight systematic and work that we are doing in the domain. Yeah.
Got it. No, that's pretty fascinating to hear. So you're using the containers which are given by AWS, like an entry point script, and then you just load it and then let AWS take care of everything else, right?
Yeah.
Got it. No, that's super interesting. And I think that's useful for, I think, companies which are earlier starting out to help, like for them to also understand and like how to quickly deploy these things, right?
Sure.
So just last question from my side, and then I'll probably hand over to Aishwarya. So between latency and model accuracy, right? So these are like two edges. You can make a super big model with a very high latency and like a really low latency model with a like not so great accuracy, right? So between that, how do you achieve the trade-off and how do you make those decisions that what is the right way to go about it? How do you make latency versus accuracy decisions?
Well, that's a great question. Usually the accuracy is the hard, constraint for us from the API and the software engineering to make sure that we are working that level, because once you're not working that level, you use the customer, experience, which is it's a very expensive thing. So we wanted to, it is the hard, constraint that we have. It should be less than 200, 150 milliseconds for the API point of void. So to achieve that one, to make sure that we are working in a good level of accuracy, for those kind of the use cases, we use some techniques that I mentioned about the funneling one, how to have the very fast model to try to make sure we have the high recall to select the correct users, or correct level of the product for that kind of experience. And then we have the very high precision model. We work with the less inputs, not high rated inputs, to drive the final decision. So this is the main technique that we are using, and also scaling the inference endpoint could be something that we got, scaling the the number of containers and number of the the nodes. We try to achieve that kind of the latency. So these are the two main techniques that we are leveraging. And the third one is that in a couple of use cases, we also use the cache data because they are very fresh and close to the, and the high, have a very low latency to recall them, as an inference input. And we use those stuff to make sure we are satisfying the SLA that comes from the, the software engineering group and API group for us.
Got it. So you're saying there are two methods that you use. One is like a pre-cache. So if the inference takes too much time, you basically try to pre-cache those results. And the second is, again, you design for latency of like whatever is given from a business standpoint and try to get the accuracy to as high as possible where it can be like a production release. Right?
You're right. Yeah.
Got it. No, this is super helpful. Yeah.
No, I think this is great. Like I would like to understand that how do you manage and scale your infrastructure for inference as your usage grows?
And that's a great question. Once we use the usual suspect and techniques in the software engineering and the architecture in a way that, once we provide our inferencing, and the APIs. So one technique is that to provide the auto scaling for our inference point, that when the request comes a lot, we are going to use that, scale up the nodes on that. The other thing is that depends on the use case. We think about if the batch model is reasonable in that area, So we do the pre-computation. So once you have the pre-computation, you can have the save data and pre-cache cache data in the kind of Cassandra or DynamoDB, for the fast access. So you pre-compute the data to make sure that once the big load happens, it automatically and going to scale it up, and you get the good SLA for the customer. So that kind of the approach is kind of the serverless we do. So we don't think about how we need to add our auto scaling in the infrastructure.
Got it. No, definitely this is quite insightful. And one last question from our side is that, can you discuss any best practices or tips for other ML engineers who are looking to deploy their models in production based on your experience?
Cool. Yeah, sure. Yeah, based on my experience, this is one thing that I want to emphasize. ML is roughly, I don't say that's very new, but roughly new, in the industry environment. So it is very important to initially to make sure that you're focusing on the correct problem, to get the buy-in from all the stakeholders. That the problem, to make sure that it's really solved. This is something that they need and solve the problem. Because once you interact with many different, cross-functional, stakeholders, they have the different perspective, and sometimes they don't have the, background in the ML. So understanding that you're solving the correct problem is I think this is one of the most important part. The second part is that it's important to use from my experience, using the proven open source solution like Spark, TensorFlow, and other cloud service could help a lot to make sure that you're correctly deploying, and not spend much time about just writing anything from the initial point, from the scratch. So that could help a lot, because sometimes based on my experience, we just forgot the real problem and just stick to write the initial solution for the ML platform, on that one. But the main problem is that we need to solve the business problem first for whatever ML is. So, and once we get the good result, we can think about how we optimize and maybe use the cloud or other open source in this domain. Something that we did, for example, for Kubeflow, the switching from the Airflow to the Kubeflow. Once we get more credit maturity, in that domain. So to be fast, to be frank, is very important to drive the result. And the third one is that I think once you start a project, it's good to start small, not try to boil the ocean, and get the good result and incrementally go to the best model or best, solution. So because sometimes to grasp and understand the problem is hard. There are lots of ambiguity once you also scope the problem, but start small and move fast to do a fast implementation of the ML operation. The other thing that comes to my mind is the use containerization. This is the important one. This is the best state of art in the software engineering and the service-oriented architecture. So use that concept to containerize your models, have the different models, and you play around. That helps you a lot to get rid of the complexity inside of the model and just see them as the scale up down containers and as a abstract. So you can play out and shows your work in a library fashion. Just you have a good library and the tools and models that you can solve the problem. And once you do that, it's very important to do the monitoring the performance of the models. Really, to have the good observability pipeline around that is very important to make sure that the offline metrics is also in a good range. Also there is no jitter in the model, because in many cases you need to update model very frequently. This is the very critical part. So that retraining, automation retraining is the critical point that you should consider at the end in your pipeline and ML ops operation. Once it's getting mature. And the other things that I think it's important is that for some applications, because of right now the AI emerge, you see that the privacy security is very important. So have a good connection with the privacy legal thing to make sure that you're focusing and using the correct data to make sure that the user, privacy user and the security also preserved. something related to the ethical path of the AI using and the legal path of the AI, but it's also good to consider because for our company, for my group, we have the regular chat with those people related to legal and privacy to make sure the models that we are generating just respecting the people, privacy, and we follow the legal issue in that domain. So this is also very important. And lastly, I think I just mentioned about that updating the model is very important because we are in the area that the user behavior may change a lot, the market, the domain. So thinking that as the main dish once you develop the model is very important. It's not something that you just play a model working for some period and it's good. So the maintenance of a model is something that you should pay attention and invest on in your MLOps and in your operation.
Yeah. No, I think definitely these were some really great actionables, Reza. And I think for all the questions you have given very interesting techniques, which I am assuming people who are watching the video will be able to implement at their work, right? So I think, I think these were our questions. It was great chatting with you. I hope you enjoyed the experience. Thank you so much once again for joining us today.